There are 5 parameters used to measure strength of acids and bases. Before I delve into these 5 parameters, I would want you to have an idea of what strength is. If you put a tip of sodium chloride inside a glass of water and you put 20 spoons of sodium chloride inside another glass of water, you don't need to be told that the fluid from the second glass is strong and the fluid from the first glass is weak. Remember, salt dissociates in water. So when we talk about strength of acid and base, we are talking about the concentration of the ions produced after dissociation in water. Gives us the idea of what strength is. So number 1 parameter that is used to measure strength of acid and base is what we call Ka and Kb. Ka means acid dissociation constant. A stands for acid dissociation constant, while Kb means base dissociation constant. If this is an acid, Ha is an acid. Once it is dissolved in water, expectedly, this Ha must ionize, form ions, producing hydrogen ion and acid radical ion. Now, the acid dissociation constant is the equilibrium constant of this acid ionization equation. From the law of mass action, we have rate of forward reaction, R1. Forward reaction is when this acid breaks into H plus and A minus. Forward reaction. Backward reaction is possible when these two ions combine to form the acid. That is the second rate of backward reaction. So according to law of mass action, the rate of reaction is directly proportional to the active masses of the reactant. Now, if we remove proportionality sign, R will be equal to K times the active mass of the reactant. Now, for forward reaction, R1 is equal to K1 times the reactant of the forward reaction is Ha. So the active mass of Ha is Ha enclosed in this bracket. This bracket entails the concentration of Ha, the acid. For backward reaction, R2 is equal to K2 times the active mass of the reactants 2. So for R2, the reactant is now the product of this equilibrium reaction. These are acting as a reactant since they combine to form this. So the reactants are H plus concentration of hydrogen ion times concentration of acid radical. If you divide this R1 with R2, let's do that. R1 divided by R2 will give us, since the whole R1 means this, we say K1 times active mass of Ha divided by R2, which is this, K2 times active mass of H plus times active mass of A minus. So what we now have is that R1 over R2 will give you K1 over K2 times active mass of Ha divided by this. We continue. K1 is the constant of forward reaction. K2 is the constant of backward reaction. Equilibrium constant is the ratio of constant of forward reaction to constant of backward reaction. Therefore, we can say that K1 over K2 equals to K. And in this case, we are talking about acid, so it's Ka. This is the equilibrium constant of acid dissociation. Or you can say this is acid dissociation constant. Now let us replace K1 over K2 with Ka in this equation. R1 over R2 equals Ka. At this juncture, you have to remember something. At reaction equilibrium, the rate of forward reaction and the rate of backward reaction are equal. They are the same. Which means R1 and R2 are the same thing at equilibrium. R1 is the same thing as R2, which means R1 over R2 is 1. If R1 is 20, R2 is 20. 20 divided by 20 is 1. So R1 over R2 is called 1 here, equals Ka times this. Now we make Ka the subject of the formula. Ka is equal to this one now, divided by this. But we can change division to multiplication immediately. So instead of writing this over this, we write this over this, and that is, and this multiplication can be dot. And 1 times anything is that thing. 1 times anything is that thing. So we can equally remove this one and just say, bear in mind it is 1 divided by this, which is the same thing as 1 times this over this, and 1 times this over this is this over this. So we write it there. H plus dot A minus divided by HA. So this is a value of equilibrium constant of acid dissociation. It is a measure of strength of an acid. How is it a measure of strength of an acid?